So let's start our next topic, that is Bohr's model of atom. So actually, Rutherford model, that was failed. So in order to overcome the limitations of that Rutherford model, atomic model, Niels Bohr in 1913 proposed a new model of the atom on the basis of Planck's quantum theory. So that model, it was primarily applicable to hydrogen atoms. It was applicable to what? क्या हो रही है? Oh, sorry. Presentation. Wait. Now is it okay? Okay, so what I said, that in order to overcome the limitations of the Rutherford's atomic model, Niels Bohr in 1913 he proposed a new model of the atom on the basis of Planck's quantum theory. And this model, it was primarily applicable to hydrogen atom and to one electron species. What do you mean by one electron species? The atoms having only one electron. For example, helium plus, lithium 2 plus, beryllium 3 plus, like that. So first point of this model is that in an atom, electrons revolve around the nucleus. In atom, electrons, they revolve around the nucleus in circular paths. And see, it is written as definite circular paths. And these definite circular paths are known as orbits. And the corresponding energy of the electron is, and what is the energy? See, each orbit is associated with definite energy, and therefore these are known as actually stationary states. So what do you mean by stationary states? They are also known as energy levels or energy shells. And why they are known as stationary states? Yes, tell me. Why they are known as stationary state? Because and each orbit is associated with fixed energy. Means as long as electron is revolving in the same orbit, its energy remains same. It will not change. It is fixed. It is definite. That's why these energy levels or energy shells is 1, 2, 3, so on. This first is called K shell, L shell, M shell, N shell. These are called stationary states. Yes, beta, is second postulate. Did you get it? Okay. Now, as this orbit is associated with a definite energy, so what type of orbits are permitted? So he said only those orbits, those energy orbits are permitted for the electron in which the angular momentum, what is angular momentum? Mass into tangential velocity. What is tangential velocity? That when electron is revolving around the nucleus, like this tangential velocity, as it is revolving around the nucleus, and if we free it when it is revolving, just like a stone is attached to or tagged to um, a rope, and we are means rotating that rope, and suddenly we free it, so it goes tangentially. So the velocity attained by that particular thing, that is called tangential velocity. So tangential velocity of the revolving electron into radius of the orbit. So this mass into tangential velocity and radius of the orbit is called angular momentum, and that should be equal to integral multiple of h upon 2 pi. H we have taken from E equal to h nu. What is that? Planck's quantum equation, you know. Planck's quantum theory, according to that, energy is emitted or absorbed by any body discontinuously in the form of small packets, and that energy is called E equal to h nu. And that h is called Planck's constant, and its value is fixed, that is 6.626 into 10 raised to power minus 34 joule second. That is the value of Planck's constant. This means angular momentum of the electron is quantized. Angular momentum of the electron is quantized. Okay, so see, this part we have done. As long as electron is present in a particular orbit, it neither absorbs nor loses energy, and its energy therefore remains constant. And because of this, these orbits are called stationary states. Now, next point is when energy is supplied to an electron. See, let us say electron is at level 1 and this is ground state. Yes, beta. This is ground state. Okay, this is ground state. E1 is ground state. So when it absorbs energy, it goes to the higher level, and that is called excited state. It jumps to higher level when it absorbs a fixed amount as quanta, and it jumps to higher energy state, and energy which is absorbed, that is equal to E2 minus E1. This much amount is of energy is absorbed. This much energy is absorbed. And excited state, electron in the excited state is unstable, so it may jump back to lower energy state, and in doing so it emits energy of the same amount of energy it emits. This case there is emission of energy. Here energy is absorbed, in this case energy is emitted. Equal amount of energy is emitted. So what are the postulates? First postulate is that electrons are revolving around the nucleus in circular paths, and these circular paths are called orbits, and energy associated with each orbit is constant, that is fixed, and that's why they are known as energy levels, energy shells, okay, or stationary states. First shell is called K shell, second called L shell, third is M shell, and fourth is N shell. And then only those orbits are permitted in which the angular momentum of the electron is equal to integral multiple of h upon 2 pi. M is mass of the electron, V is its tangential velocity, and R is radius of the orbit. And H is Planck's constant, N is any number, integral number, 1, 2, 3, 4, so on. And next is, as long as electron is revolving around the nucleus, and as long as it is revolving in the same particular orbit, its energy is fixed. It neither lose energy nor gain energy. Its energy remains fixed, and that's why these are called stationary states. Energy shells are called stationary states, and this MVR equal to NH upon 2 pi. According to it, angular momentum of the electron is quantized. Okay, and if electron absorb energy, it is excited from lower level to higher level, and energy is absorbed equal to the energy difference between the two energy levels. And if electron jump back, because in excited state electron is unstable, so it may jump back, and when it jump back, energy is released, again corresponding to the energy difference between the two levels. Okay, so now next part is that the most important property of an element is of an electron is energy of its stationary state. Let us say its fifth point. First point, second point, third, fourth, fifth we have discussed. Now sixth point, energy of its stationary state. Energy of electron in nth stationary state. So energy of the electron in nth stationary state, it is given by minus RH into 1 upon N square. N is 1, 2, 3, so on. This is for hydrogen atom. Keep in mind, for hydrogen atom, and here RH is again Rydberg constant. But now unit has been changed, because in last case we have wave number. We have written 1 upon lambda equal to nu bar equal to RH. Remember? So Rydberg, again it is Rydberg constant, but now its value is 2.18 into 10 raised to power minus 18 joule. See, we have put negative sign before the expression. So what it means? What is the significance of negative charge? Yes, beta? Oh, beta, that is the energy difference between the two shells. When electron jump from one level to another, or it fall back from one level to another, it is the energy of the electron in the nth stationary state. So when electron, see, I come to that part, but first tell me what is the significance of negative sign before this expression. What is the significance of negative sign? Means negative energy. What is the significance of negative energy for the electron? And why electronic, or we can write it like this, why no, that is not the case. So if question is why electronic energy is always negative, so see what we have to write. Actually, energy of the electron at infinity, energy of the electron at infinity, that is taken as zero. What I said, energy of the electron at infinity. Infinity means when it is free from the attraction of the nucleus. Infinity means electron is not in the atom. Got it? It is very important point. Electro energy E infinity equal to zero means E infinity means energy of the free electron. Is free electron means when it is not in contact with the nucleus, it is not associated with the nucleus, or it is free from the attraction of the nucleus. Because if electron is in the atom, it is always in attraction with the nucleus, because nucleus is only the force which hold the electrons in the particular shells. Got it? Because if this attraction from the nucleus is experienced by the electron, this is the reason that electron is revolving around the nucleus to maintain its distance from the nucleus. Okay, that centrifugal and centripetal force, I'm not going in detail. Simple is that energy of the free electron is supposed to be zero. It is not zero actually. It has some energy, but for our convenience, what we do, we take its energy as zero when it is totally free. Now, when this electron is in the atom, that means it is in one of the level closer to the nucleus, means any level of the atom. If electron is in that level, that energy level, in that energy shell, then that is in attraction with the nucleus. So that means electron comes back from infinity to that particular shell. So what happened? Energy is absorbed or released? If at infinity it has maximum energy. If electron goes away from the nucleus, see, just look at it. Electron, if it is going away from the nucleus, then what would happen? Then there is no attraction between, means attraction is decreasing. Attraction is okay. See, this is nucleus, okay, right? Now this is the first shell, second shell, third shell, fourth shell. I'm going to write all the possible shells, okay? How many shells are possible? Infinite. Okay. Now tell me, if electron is in the second shell, see, this is the, for hydrogen atom, this is the ground state, right? Because electron is in the first shell. Now, for the same electron, this is first excited state. This is first excited state. And third shell is second excited state. So let us say electron is in the second shell, means in the first excited state, and it fall back to 1. So now tell me what happened. Energy is absorbed or released? You can see this context. This one. E2 to E1. If electron fall, jump back, energy is emitted. Energy is emitted because now it feel more attraction. In the first shell, it feel more attraction. In the second shell, it feel less attraction. Third shell, fourth shell, attraction goes on decreasing. So energy goes on increasing. Means E1 is at the minimum energy level, order of energy C. E1, E2, E3, E4 and so on. As N increases, energy increases. Energy is directly proportional to N because there is a negative sign before the energy. See, if N increases, energy becomes less negative. If N increases, energy becomes less negative. What it means? It increases. Say minus 30, obviously minus 20 is above, minus 10, minus 5 and ultimately 0. So maximum energy of the electron is 0. So whenever electron is in the atom, that is, it is in one of the energy level, so electron jump back. Electron jump back from infinite to that particular shell. So overall energy is released when electron come from infinity to particular shell in atom. That's why energy of the electron becomes less than 0, because maximum energy at infinity it is 0. So when it comes back from infinity to the particular shell, then energy decreases, energy is released, so it becomes less than 0. That is, it becomes negative. It becomes negative. Got it? So electronic energy is always negative. Keep in mind. Okay. Now come to that part you are asking for. That let us say that electron is in the N2 level and it comes jump back to N1 level. N2 is greater than N1. N2 is higher level, N1 is lower level. So what is the energy at the N2 level? It is minus RH into 1 upon N2 square. Right? See this expression. En equal to minus RH 1 upon N square. So in place of N it is N2. So En2 equal to minus RH 1 upon N2 square, and En1 is equal to minus RH 1 upon N1 square. So now what is delta E? Delta E equal to En2 minus En1. So En2 is minus RH N2 square minus RH N1 square. So this is the expression. So it becomes minus RH 1 upon N2 square minus plus RH 1 upon N1 square. So RH is, take it as common. So 1 upon N1 square minus 1 upon N2 square. This is delta E. And what is RH? It is minus 2.18 into 10 raised to power minus 18 into 1 upon N1 square minus 1 upon N2 square joule per atom is joule, and it is joule per atom actually. So now it is for hydrogen atom. For any one electron species like helium plus, or helium plus, what is that? 2, lithium 2 plus, Z is equal to 3, because for hydrogen atom Z is equal to 1, so we are not writing Z here. But if we have one electron species other than hydrogen, then it is minus RH Z square over N square. If Z square is also attached, then is in that case delta E becomes minus 2.18 into 10 raised to power minus 18 1 upon N1 square minus 1 upon N2 square into Z square. Okay, and this is the expression for hydrogen. See, so it can be written as delta E of any species, any one electron species, is equal to delta E of hydrogen into Z square, or E n of any species is equal to E n of hydrogen into Z square. But are you getting these equations? Little bit. Why is it so? See, simple thing is, just keep in mind this equation. That's it. En equal to minus R minus, you know why I write minus? Because electronic energy is always negative. And why is it so? Because energy at infinity is taken as 0. So whenever electron fall into the atom from infinity, energy is released that become less than 0. So negative sign is because of that. RH is Rydberg constant, and in terms of energy, its value is minus 2.18 into 10 raised power minus 18 joule, and 1 upon n square. That's it. And if other than hydrogen is there, then we put a Z square above it. Okay. So now we have this expression that, and delta is always final, is upper minus lower means higher energy level minus lower energy level, and this much energy is released. This much energy is emitted. This much energy is emitted. Now, from this expression, delta E equal to this. Fine. Let us say for hydrogen atom, we have written delta E equal to 2.18 into 10 raised to power minus 18 into 1 upon n1 square minus 1 upon n2 square joule. So now frequency for the absorption and emission of the photon we can calculate from this. Now frequency corresponding to this is the energy emitted if electron fall from higher level to lower level, and this is the energy absorbed when electron, just write first this thing, energy delta E is absorbed when electron jumps from n1 level to n2, and this same energy delta E is emitted when electron jumps or fall back from n2 to n1. Now, when this energy is absorbed or released, that is always in the form of quantum, and the frequency nu for the absorption and emission of the photon. So let us calculate. Delta E is equal to h nu according to, what is the name of this theory? Planck's quantum theory. So according to it, nu equal to delta E over h. So delta E, what is delta E? RH 1 upon n1 square minus 1 upon n2 square. So just put the value. RH is 2.18 into 10 raised to power minus 18, and H is 6.626 into 10 raised to power minus 34. Above value is in joule and denominator value is in joule second. It is in joule second. So when we divide it, value comes out to be 3.29 into 10 raised to power 15, 1 upon n1 square minus 1 upon n2 square per second, or we can take it as hertz. 1 per second is hertz. This is the frequency. Now from frequency we can calculate wave number. That expression we have written already. Wave number nu bar, that is equal to 1 upon lambda, and you know lambda into nu equal to c. So 1 upon lambda is equal to nu over c. So now wave number nu is 3.29 into 10 raised to power 15 per second, and c is 3 into 10 raised to power 8 meter per second into 1 upon n1 square minus 1 upon n2 square. So now if we divide it, so value comes out to be same as we have written before, that is 1.09677 into 10 raised to power 7 1 upon n1 square upon 1 upon n2 square per meter. This is wave number. So these are the three equations. I will write them again. First is delta E, that is energy absorbed or emitted when electron jump or fall n1 and n2 in between n1 and n2, and that is equal to 2.18 into 10 raised to power minus 18 joule 1 upon n1 square minus 1 upon n2 square. Second expression is frequency of quantum, or we can say frequency of the photon absorbed or emitted, so that is equal to 3.29 into 10 raised to power 15 per second 1 upon n1 square upon 1 upon n2 square, and then last is wave number, and that is equal to 1.09677 into 10 to the power 7 per meter 1 upon n1 square minus 1 upon n2 square. Yes, beta. Got it? These expressions you have to keep in mind. Wave number of photon. Okay, so this is about Bohr's model, and then Bohr theory is also used to calculate the that radius. What is the radius of the Bohr orbit? Okay, so radius of Bohr orbit, that is radius of nth orbit. The radius. So what was the relation? Yes, beta. For radius. Yes. Have you? Hello. Yes, beta. Radius. What was the radius of the nth orbit? That is called Bohr's radius of the first orbit is called Bohr's radius. What is the formula? Hmm? Yes, yes, yes. Radius of nth orbit is Both radius into n square for hydrogen atom, and radius of the nth orbit is Bohr's radius into n square over z for hydrogen like species. Hydrogen like species means helium plus, lithium 2 plus, beryllium 3 plus like. Okay. So what is A naught? A naught is equal to 0.529 angstrom, or it is equal to 52.9 picometer. That means the radius of nth orbit is equal to 0.529 into n square angstrom for hydrogen atom, or it is equal to 52.9 into n square over z picometer, or write it for hydrogen like species. Okay. And for hydrogen like species, we divided by z. So this is all about Bohr's theory. Now, achievements. The first achievement is Bohr's theory has explained the stability of an atom. Rutherford was unable to explain the stability of the atom because, according to him, if we follow that electromagnetic wave theory, then electron ultimately fall into the nucleus. But he explained that as long as electron is revolving in the same particular orbit, its energy remains same. It neither loses nor gain energy. But Rutherford could not explain, and according to electromagnetic wave theory, that electron should follow the spiral path and ultimately fall into the nucleus, and time taken is only 10 raised power minus 8 seconds, means it should be highly unstable. But atom is stable. That could not be explained by Rutherford, but Bohr's theory has explained it successfully. It also explained the line spectrum of hydrogen, and it explained line spectra of single electron ions like helium plus, lithium 2 plus. And Bohr's theories has helped in calculating the energy of the electron in hydrogen atom and one electron species. That mathematical expression we have written for the energy in the nth orbit, and that was En equal to minus RH into Z square over n square, and that energy is minus 2.18 into 10 raised to power minus 18 joule into Z square over n square. This joule is per atom. Okay. If we take another units, then energy is equal to minus 13.6 electron volt Z square over n square. This energy is equal to minus 1312 kilojoule per mole Z square over n square, or it is equal to minus 313.6 kilocalories per mole Z square over n square. These are the different units, but in NCERT only this equation is written. You can remember all of this. In electron volt it is minus 13.6 joule per atom, electron volt per atom. In kilojoule per mole it is 1312. In kilocalories per mole it is 313.6. Okay, limitations of Bohr's model. This theory could not explain atomic spectra of the atoms containing more than one electron, or we can say multi-electron atoms. He could explain the line spectra of hydrogen atom and hydrogen-like species, but it could not explain atomic spectra of hydrogen of atoms containing more than one electron, means multi-electron atom. And Bohr's theory failed to explain fine structure of spectral lines. The spectral lines split into 2 or 3 lines that could not be explained by these finer details could not be explained by Bohr, and Bohr theory could not offer any satisfactory explanation of Siemens effect and star effect. What is this? Splitting of spectral lines. Splitting of spectral lines in the present. What? No, see, splitting of spectral lines in the presence of electric field, that is called Stark effect. And splitting of spectral lines in the presence of electric field, a magnetic field, that is called Siemens effect. Simply keep in mind only the definition. Nothing else is required. In splitting of spectral lines means one line split into number of lines. Like this is one line that's split into number of lines. One line to 2 lines, 1 into 3 lines. Such splitting of spectra in electric field, that is called Stark effect. In magnetic field, that is called Siemens effect. That could not be explained by Bohr. Bohr theory failed to explain ability of atoms to form molecules, that is chemical bonds. Why chemical bonds are formed, that could not be explained by Bohr. And above all, it was not in accordance with Heisenberg's uncertainty principle, that we will do in the next class. But it was not in accordance with the Heisenberg's uncertainty principle. So this is all about Bohr's atomic model. So far we have different formulas that I will summarize today. First formula we have done, that is delta lambda into nu equal to c. Remember it? That is lambda is wavelength into frequency, that is c, and wave number, that is equal to reciprocal of wavelength. Then we have E equal to h nu, that is Planck's quantum theory, energy of the photon. Then we have photoelectric effect, that energy of the incident photon is equal to threshold energy plus kinetic energy, or h nu equal to h nu naught plus half mv, where nu is energy of the frequency of the incident photon and nu naught is the threshold frequency. Or this E naught can also be written as work function of the metal, W naught, or it can also be written as half m v square equal to h nu minus h nu naught. Then we have, yes, wave number, that is equal to 1 upon lambda, that we have done today as well, 1.09677 into 10 raised power 7 1 upon n1 square minus 1 upon n2 square for hydrogen atom in per meter. In per centimeter it becomes 10 raised to power 5. Then delta E, energy absorbed or emitted, that is equal to minus 2.18, sorry, not minus, simply 2.18 into 10 raised per minus 18 joule 1 upon n1 square minus 1 upon n2 square. Then frequency 3.29 into 10 raised to power 15 1 upon n1 square minus 1 upon n2 square per second. And last one is radius of the nth orbit equal to 0.529 into n square for hydrogen atom and n square over z for any one electron species, or 52.9 into n square over z picometer. And if we explain all of them for any atom is one electron species, then they all should be multiplied by z square. Only we multiply them with z square, then we get the equation for any species of one, means any one electron species. Just multiply them with z square. Into z square that's it. So these are the formulas that you have to keep in mind. Yes, one more. Energy of nth orbit, that is minus 2.18 into 10 raised per minus 18 joule into z square over n square. So these formula you have to keep in mind. Okay, I will send this PDF. Okay, then thank you. Okay, bye bye. Okay, so this is all about today's lecture. Today we have covered Bohr's atomic model, its achievement, its limitations, all the and failures of Bohr's model, and what he predicted, like radius of the nth orbit, energy of the nth orbit, how much energy is released or absorbed when an electron jumps from one level to another, or what is the frequency associated with it, what is the wave number associated with it. That all we have done today, and we have applied Planck's quantum theory to do so, because delta E equal to h nu. So frequency we have calculated like hc over lambda. So wave number we have calculated. That's all for the day. We will do all the class 11th concept, NCRT examples, it's in text questions, exercise questions with complete explanation, and after that we will do JEE and NEET questions of each and every chapter for your competitive exams, and this is all free of cost. So do take advantage of this free education drive. I will definitely help you to crack your NEET or JEE exam, any competitive exam, and at the same time score good marks in your school exams and board exams. To support my channel, subscribe and share my channel with your friends as well as your college um, classmates, and share in your community groups as well. That's a great help to me as well as grow my channel. Thank you so much to be with me and to support my channel. Jai Mata Di. Namah Shivaya.